This is a problem from one of your lab assignments, section 5.2. Use the form of the definition of the integral given in the theorem to evaluate this integral. So we have this integral from -2 to 2 of 1 plus 3x dx. So the interval from -2 to 2 has to be broken down into n equal subintervals. And we want to find the width of each of those subintervals. That is called delta x. And the formula for that is to take the difference between a and b, the -2 and 2, and divide it by n. So we have 2 minus -2. That's just equal to 4. So that should be our delta x. Our first point in this broken down subinterval is going to be -2. So after -2, we're going to take steps of delta x. So each x sub I is going to be the starting point plus however many subinterval steps we've taken times delta x. So our delta x is actually equal to 4 over n. So this is going to be 4 over n times your I variable here. So let's make sure that we include I. Now we're going to use the series expansion for the integral. And it doesn't really matter whether we use the left hand or right hand, because we're going to go to set up n arbitrary intervals, and then we're going to take the limit as n goes to infinity. So our function 1 plus 3x will go into the summation 1 plus 3x, and then for each x we're going to substitute x sub I to say that we're going to substitute the right hand endpoint of each of the subintervals. This is the function, and the function represents the height of the rectangle, and the base of the rectangle is represented by our delta x. So we put in the appropriate values. We have the 1 plus 3 times x sub I. Now this x sub I is the value of x sub I that we got from step 2. X sub I is going to be -2 plus I times delta x. And remember that delta x is 4 over n. So the whole expression of x sub I is given here. And then we want to multiply that by delta x. Now this 4 over n has no I components in there. So the 4 over n can be taken out of the summation sign. It is not dependent on the index I. Aside from that, we just simply need to do some simplifying. We have 3 times -2. That will be -6. And then we have this extra 1 here. So we have -5 for the constant. We have 3 times 4 times I over n. So the I over n is already covered here. So the only thing we need to fill out is the 12. Now we're going to break this apart into two different sums. We have -5 and we have 12I over n. So we have the sum of -5, and then we have the sum of 12I over n. Now, just like we took out a 4 over n earlier, the 12I over n has a factor of 12 over n, which are not dependent on the index. So that can be taken out also. And technically, -5 can be taken out of this summation sign as well, and then we would just have the sum of 1. So let's take a look at each of these sums. So the first sum here is a sum of -5 as I goes from 1 to n. And so imagine taking this -5 out and then the sum of 1. The sum of 1 from 1 to n is just going to be n. So here we're going to get -5 times n. And by our formula, the sum of I is going to be n times n plus 1 divided by 2. So now we can put these in place of the sum, and the first one is going to be -5n, and then the second one is going to be 12 over n times that n that we found. So now let's multiply the 4 over n through. Multiplying that through this first term, if we multiply it by 4 over n, the n's would cancel and we would get -20. That's 4 times -5. And for this one, it looks like they took out a factor of n plus 1 over n. So what do we have left? We have 4 over n times 12 times 2. So that's 4 times 12 is 48, divided by 2 is 24. So we have a constant 24. One of the n's cancel. Let's cancel out this n with the numerator n. So pretend those n's are gone, and then this n came underneath here. So we just have the constant 24. Okay. Now we take the limit as n goes off to infinity, and here we can just divide by n, and so we have 1 plus 1 over n divided by 1, and then as n goes off to infinity, 1 over n will go to 0, so that's just going to be 1. The other way to do this, the fancier way to do this, is to use L'Hopital's rule, where we take the derivative of the numerator and the denominator, and then we get 1. So in either way to do this, you're going to get 1. So you essentially have -20 plus 24, and that's going to give us a positive 4. So that is our integral. Okay, I hope that helps.